I think, what do you want us to walk away with? I'm a philosopher, ethicist. I'm not an astrophysicist.
Mm-hmm.
What do you want me to walk away with, and how should I use it in my, whether it's church, at work dialogues, just something along those lines? Let's start with you, Jeff.
Well, I'm gonna give two things. Okay. I know you said one,
you
but
can't do three.
I'm not. No, that would be a good sermon, but I'm not going to do a sermon.
Yeah, I'll start with E too.
Yeah, I like Q, but no. Two things. That one, that at the end of the day, every time we have new advances, build new instruments, we're going to get more information about creation. But if you're worried about will this somehow go against Christianity, it just won't. I mean, if God's the creator of the universe and the author of creation and the inspiration for Scripture, they're never going to contradict. And so just to have that realization was foundational for me a few decades ago of just, I don't have to be worried. And so I can go out and learn and be excited about it, which gives me a confidence going and talking to people. So that's why I really want that, is so you have a confidence in talking to people. And the other part is, not only is there the kind of the intellectual data, we can make good arguments, but that's important, but there's also the feeling, the grandeur, the majesty, the care, to not just making an intellectual argument, but having the experiential, I feel it as well. Because I think that's how we're made, and you're going to be able to connect with more people if you have that. And I've just seen that woven throughout all of the talks that I've seen here today.
That's good. What if someone said to you, well, it just sounds like you're not open to being wrong? That you're so confident, right, going into it. I could just hear someone saying that.
I guess I see confidence is less about, to me, confidence isn't I'm always stating things as though I know what's going on. The confidence is when something comes up that I don't know, I'm like, oh, I hadn't heard that. Being willing to listen, and so somebody else is the expert or knows more about it, just take the time to learn from them. Or somebody challenges you, it's like, well, be willing to go in and explore the challenge instead of feeling like I've got to give the answer, I need to avoid. Being bold enough to go in and say, let's go see where this leads, knowing that God is who he says he is, and he's going to come out victorious, whatever you go explore down there.
So the confidence actually makes you more open.
Exactly, yeah.
To the dialogue. Good.
Amen. Yeah.
Good. Let me jump over to Jack. How would you answer some of that? What did you kind of learn today? What do you want us to take away with how to use it?
Well, I loved listening to all the other fellows talk. I mean, so that the grandeur of it all, and you know that comes through. There's also the factor of human ingenuity and resourcefulness that's at work in producing this. Christians, we do want responsibly to talk about our fallenness and the ways in which our nature has been corrupted and so forth. And I think that was actually mentioned in the very first talk from Pascal. And that's true. And nevertheless, a human being is a really magnificent creation. Mm-hmm. And what I would love is if people heard from Christians a real appreciation for the magnificence of humans, and so that we're affirming all that's magnificent about humans, and we're mourning the ways in which the fall of our first parents have corrupted those magnificent things. Aristotle wondered about human beings being born with weapons or tools, the same word that Paul uses, let your members be tools for righteousness. And Aristotle marvels that humans are born with these tools for righteousness, but they can use the same tools to commit incredible wickedness. And that what they should hear from us is not, oh, you horrible people, but rather, this is really deeply sad. Mm-hmm. So it is so wonderful to hear about this kind of achievement of people who have really, and they work together, they work magnificently.
Others could answer this, but I'll throw it to you. We can get 10,000 people to be unified on a project like this. What if someone said, why can't we do that to solve other problems in life?
Yeah, well, and that's, personal agendas always come into play and so forth. Yes,
You have a thought?
Yeah, I think we can actually get together on other problems as well with the experiences we have. We've been incredibly lucky and blessed that we could build the Webb telescope, but it was because before that time Hubble was done. A lot of lessons were learned and a lot of heritage made it from Hubble and other platforms into Webb. And one of the things I learned today is, from the various talks, how wonderful it is that we live in this privileged time and that God gives us these tools, sort of like Psalm 8 says, he's made us in his image. Not how is it worded exactly? I can't remember, but the spirit of the psalm is that he made us almost godly, not quite, but he gave us his talents to ask these questions and get good answers, and answers that contribute to our understanding of the universe and our understanding of the Creator. And that's special, I think. I think we can do it in other areas as well, science areas, maybe social areas.
As a scientist, Thomas, who was the chief science officer that oversaw the project, right?
Yeah.
He had to write 2 letters before the launch.
Yeah.
One was on behalf of its success.
Yeah.
One was on behalf of if it failed.
Yes, that's right.
If it had failed, what would you say to people to continue doing this kind of work?
I would say many of these great successes are built on previous failures. The Webb telescope would have never been as good as it was had we not learned from the initial. The first 3.5 years of Hubble were an unmitigated disaster, right? Maybe most of you are too young to remember this, but I got tenure based on aberrated Hubble data. I still feel guilty about it. But we learned a lesson from that. And had the mission failed, that would have been tragic, but we would have learned lessons. And you build these missions to succeed, but you're constantly aware that you could fail, and you try to find every pitfall and every mistake you made or could have made, and avoid it or fix it up.
Yeah. The tenaciousness, that's what amazes me of all these engineers and scientists and all the workers, how they work so hard on that. Yeah. That's good. Hugh, you want to kind of back clean up there on some of these thoughts?
Yeah, I think of the Bible verse, my people perish for a lack of knowledge.
Yeah, exactly.
And yet we have in Daniel 12 that in the last days, knowledge will explosively increase.
Yeah.
And to me, the James Webb is a testimony to just how explosively our knowledge is increasing.
Yeah.
And hopefully we can channel that knowledge into helping people recognize there's a God behind all of this. He loves you. Look what he's created. Look how vast it is. Look how finely tuned it must be. So to me, that's a significant point. The other thing is hearing the other speakers speak about, it's not just the knowledge we're gaining. There's an emotional impact we're all receiving thanks to these amazing James Webb discoveries and images. And, frequent references. The heavens declare the glory of God. Yeah. The heavens declare the righteousness of God. And yet, if you were someone living in downtown Shanghai or downtown Delhi, you look up at the sky, even on a very beautiful, clear night, you can't see a single star. You can't see the planets. You struggle to see the moon. And even during the daytime, you can look at the sun with the naked eye. And so you can say, well, the heavens aren't declaring very much to most of the people of the world today. But they are, because we can't see with the naked eye, but look what we can see through the Hubble Space Telescope. Look what we can see through the James Webb Space Telescope. So in many respects, the heavens still are declaring the righteousness and the glory of God in a way that just causes us to have this emotional sense of awe. I mean, who are we before a God who created all this? And then all the references we've heard to the beauty of what's being displayed. What is that telling us about the one that created the universe? What is it telling us about the one that created us?
So I'm going to read a quote, and this kind of goes to your talk, Roger, but anyone else can respond to the quote. I think many of you will be familiar with it. Quote, every atom in your body came from a star that exploded. And the atoms in your left hand probably came from a different star than your right hand. It really is the most poetic thing I know about physics. You are all stardust. You couldn't be here if stars hadn't exploded because the elements like carbon, nitrogen, oxygen, iron, all the things that matter for evolution and for life weren't created at the beginning of time. They were created in the nuclear furnaces of stars. And the only way for them to get into your body is for those stars that they were kind enough to explode. Mm-hmm. So forget Jesus. The stars died so that you could be here today. That was Lawrence Krauss in one of his books. Now, in some ways, it's kind of a softball to throw up and hit, but what do you say back to that, or in light of that?
Well, I'm glad that these previous stars died on the battlefield for us, but it's part of God's design that the neutron came with a 900-second decay time, so that the 3-minute hot Big Bang produced 24% helium, so that stars would shed these outer layers either through AGB stars like the sun in 5 billion years, or explosive stars like the massive ones through supernovae, shed out that material. But for that, you need to have formed helium, and we have it. But that was not a given. The stars are not persons. They just, they're matter that follow the laws of physics, and they did what they needed to do so that we could be here. We call it die, but it's a physical process. And I'm very glad, as Einstein said, that the laws of physics are the same everywhere. So if my left hand doesn't know that the right hand came from different supernova material, at least my right hand doesn't contain antiprotons and the left hand contain protons, right? They're all the same material, and it's all following the same proportions in the periodic system, and it's part of the plan.
Give a new meaning to thunderous applause.
So, that's interesting what you just pointed out, though. I mean, that the word die. Yeah. And so in the quotation that you read for us, I mean, you see what happens when somebody is being rhetorical and lets an image get away from him. Because that's what's happened there. He's let the image do the talking, and he hasn't phrased it as carefully as he should have done and as he knew well enough to do.
Thoughts?
Well, I think of two of you quoted the Bible verses in Isaiah and Psalms, how God has a name for every single star. And imagine the names he's given to the stars are much more appropriate and more colorful than the names we astronomers.
I don't know. I like GNZ11. That's just nice.
I was waiting to hear 8675309 as the name of a star.
Yeah, we're not just numbers. The stars aren't just numbers. He's given them everyone a name. And I like the way that I think that responds to Lawrence Krauss's statement. Yes, we're all stardust, but look at how exquisitely designed the number of stars must be. The different kinds of stars, when they form, when they die, in order for us to be here. And, these stars are giant balls of gas, mostly hydrogen and helium. Yet God actually has a name for every single one of those stars. And I think one of you mentioned how you can name 1 trillion stars after every human being and not run out. It's like, I think God knows the name of every human being. We're far more beautifully designed than any star is. And if he has an actual name for every single star, how much more does he care for every human being?
You can manage the hairs on our head then.
Yeah.
Well, for you got a little few more than I have.
Any comments?
I would just kind of, I've been thinking about this over the last week or two for entirely other reasons, is that it seems to me Krauss is conflating, we have an explanation for the physical stuff getting from there to here to actually accounting for what's gone on. That as much as I love science, I love figuring out how things work. It's part of, if science is the only world you have, it's a very small world. Whereas, yes, I can explain how carbon's formed so that I can be here and I can understand how this. But there's so much more to me than just I'm a bunch of carbon atoms. Yeah. And so if science is all you have, it's a very small world. And I think I'm kind of beginning to appreciate more and more that, like what Aquinas is talking about in his 5 ways, that there's so much more to what the world is, that if we really want to have an explanation of the world, we need so much more than just the physical material explanation. But if we want to play in that small world, that's okay. But I would rather live in a bigger world. So.
Mm-hmm.
Yeah, and I think we have to be careful, too, about the addiction. We're told that the heavens declare the glory of God. We talked about the 2 books, the book of nature and the book of scripture. I'm impressed that Jesus made the comment to a lot of the Pharisees. You're so deep into the theology, you're not really seeing what's behind the theology. We can be so deep as a scientist into the science that we don't pay any attention to the one who put it all together. And for a lot of scientists I engage who are not believers, I recognize they're addicted to their scientific research.
Yeah.
I need to help them with their addiction.
Yeah. One way I put it, I borrowed this, it's not original with me, but it's like enjoying a great gourmet meal, but ignoring the chef.
Yes, yes.
We're there to be the server and go and point people to the chef. In this case, here's a question from online. Then we're going to take some in here. Another person asks, young earthers seem excited about James Webb's findings. Would you talk about this and give some reflection? So anyone can jump in on that. You guys can ask each other's questions. So,
is there any context of what are they excited about?
I think it's partially some of the claims that was dealt already with it overturning the Big Bang.
Okay.
The evidence there. I don't have any.
Yeah, I know we're redoing our website, but I actually have an article. It was kind of interesting. About 10 years ago, something came up related to, and I was doing a search, and I found an old set of, I think it was related to the Big Bang, but just, numerous instances where young Earth creationists said, oh, Big Bang's dead because of XXXX, and now we're 20 years removed from all that. And I'm like, oh, wow, that's interesting. What they said is now solved, it's like every single problem there had not a solution, but a robust solution about it. And so, I don't know. I have to be careful how I say this. This can sound really snarky, but I'm going to try and say it rightly. I love being able to go to a museum and enjoy what I'm learning instead of always having to be on the defensive about how old Earth could be creeping in there and pervert. It's like there's just a fascination with how the world works that I can get. And being a Christian and an old Earther allows me to enjoy what science is learning as opposed to being threatened by it.
Well, again, I'm the oldest astronomer here. I can remember when there was a debate amongst astronomers. Is the universe a quadrillion years old or only billions of years old? And the young universe astronomers won. It's only billions of years old. And so, I try to share with my young Earth friends, look, we basically agree on what's important. The universe has a beginning. It was created. Our differences are on the time scale. And we only differ by 6 zeros. Why are we letting 6 zeros get between us and Christian fellowship when the atheists, they don't need just 6 zeros. They need an uncountable number of zeros to make their models work. So, can't we shrink down our differences a bit? But I think one of you made the comment, I think it was you, that the real issue is the problem of evil.
Yeah.
And so instead of focusing on the age of the universe, we need to address the really big question, the problem of evil. And I think the problem of evil, both by scientists and theologians who are Christian, hasn't got the attention it needs. And I'm also convinced the real answer comes through the integration of the book of nature and the book of scripture. Too often, scientists try to solve the problem of evil, ignoring the book of scripture, and theologians try to solve the problem of evil, ignoring the book of nature. So let's join together. And that's kind of what I try to do with my young Earth friends. Look, we have more in common than we have not in common. Let's join forces and see what we can do to spread the glory and the righteousness of the Lord that's being revealed to us.
Yep. We have a question here. Yep. The back.
Thank you very much for all the wonderful presentations today. I have a general question about science and faith, and that is, what would you say is the most sophisticated and complex thing that God has created in the physical world? And depending on your answer, I may have a follow-up question.
The human mind would be my answer.
Yeah.
Yeah, mine would be a human being. Physically, spiritually, soulishly. I mean, how do you explain all that? Nothing's more complex.
Well, a human being can live without arms and legs and so on. So if the human mind is the most complex thing created, then what is the human mind?
Great question. We've been talking about that forever.
Well, we're made in God's image.
Yeah.
Hopefully it will resemble in the right way what
Well,
God is thinking.
I mean, one of the things that I find interesting, kind of on a parallel line of investigation that I've been doing, is, we're talking a lot about artificial intelligence and replicating, or we talk about it as though we're generating artificial intelligence. But as I watch what we're doing, in some sense, we're replicating human behavior. And what I find interesting is that we're replicating human behavior in a way that we're convincing ourselves we've created an intelligent mind, if you will. And it's just kind of an odd thing that here we are as humans, we can actually think we're doing something and fool ourselves into doing something else based on how well we've done the first part. How you get that behavior boggles my mind. So,
Well, so in linguistics associated with Noam Chomsky at MIT, there's a strong push to identify their linguistic theories with their theories of how the mind works, and really interesting stuff. But Chomsky will describe, say, language behavior as a computational device, and so there's a model of how the mind works that then feeds it, at least into the MIT brand of artificial intelligence. But the question that should be asked is whether that's an adequate model. And I think it probably isn't. And as a matter of fact, linguists that aren't beholden to Chomsky have been quite critical. People who study the areas called sociolinguistics and linguistic pragmatics and so forth, they've shown that Chomsky is sort of a prisoner of his computational model of the human mind, and that does not adequately explain the ways in which humans behave individually and socially.
yeah. Say it maybe a little bit a different way of saying that same thing is that I've recognized that as a human, there's an algorithm to almost everything I do, but nothing I do is just an algorithm. And it's like that computational has that algorithmic part.
Yeah.
And it's a part, but it's not all of the part. It's not all of it. Yeah.
That's right. Yeah.
What excites me is that the more we learn about the brain, the more clear it becomes we're not just physical beings.
Yeah.
There's a spiritual component that accompanies, and how it's our spirit that controls this complex interface that we call the brain. And so, yes, there's a lot of analogies with computation, but it's like, hey, the case for dualism is getting stronger and stronger as we learn more and more about the brain. And to me, so let's look at the complex stuff and not just the simple stuff we see in astrophysics.
Moves away a little bit from our general topic here, but Ken, I know you did a number of podcasts and some articles on the soul and talking about it. That's one place to go to. On the more academic side, there's a newer book called The Blackwell Companion to Substance Dualism, and that shows a huge resurgence in these various views of dualism,
Right.
particularly substance dualism. And an accessible book that's fairly new, written by a colleague of mine at APU, he's now going over to Baylor, is by Josh Rasmussen. I'll get the title. It's something like Who We Really Are or something along those lines. It's a really good, accessible treatment of that question. So
There's part of me in another life I'd like to become a philosopher so that I can start making up new words or using the same words and making them mean very different things than what common ordinary people do. So
You scientists do that all the time.
we do. I have fair point. You're exactly. No, we're
right.
making up words entirely. I mean, at least these aren't normal words. So.
Sauce for the goose is sauce for the gander, right?
Also, I know this is popping in my head. The complexity of the mind thing. Also, as a pastor and counseling for 20 years, when you counsel people, you find out really quick that the soul is a really big thing. There's a lot there to explore. And you can do it for a lifetime. People have been married for 60 years, 70 years. There's a lot to explore in the human person. Question from online. Sorry, I just lost it here. Can you comment on? Here it is. Can you comment on a publication or publications suggesting that the Webb telescope data may place the age of the universe at 28 billion years old?
Yeah.
Yeah, I actually can.
28.
28. Yeah, I actually did a Star Cells and God about that. So to go into more detail, you would go in there. So what part of what that the person doing the research is driven by is this question of how do you get these really large complex galaxies, which some of them may not actually be as old as they are, but it's driven by that question. And one of the things they're looking at is there a way to make the universe older? And so they actually introduced, there was two acronyms, one CCC, I forget what it stood for, but then there's also a tired light. So there's two separate components of this model that are really bizarre, weird physics that have to play out, that we've got an abundance of evidence in the past showing that they don't work. And so, when I was going through my talk talking about the Hubble tension, there were 11, you could, however you did, there are hundreds of different models of how do you resolve this Hubble tension. You can always make up a model to do anything. And so this model, it matches all the data we have, but it does so at the expense of a great deal of simplicity that flows out of just standard Big Bang cosmology. So it is a viable model and there's no data that argues against it, but it also now has a version of light, whereas light propagates through space, it just loses energy from some mechanism that we can't measure, which is a really bizarre thing. It may be the case, but before we adopt this new model, let's actually see if it can be validated in some other ways. And so I just want to emphasize that it's out there published. It's a sound scientific paper, but it really introduces some bizarre ways the world works that have no physical explanation in our models at this point. So it is a pretty bizarre model.
Yeah, and Jeff is right. It's based on this tired light idea. And that's been around for over 4 decades.
Oh, a long time.
And it's been well refuted in the scientific literature. And fundamentally, what they're saying, and then there are other models that also do this, they're challenging redshifts as a reliable indicator of accurate distances, especially at great distances, which gives me some optimism because we have this technology of very long baseline radio interferometry. We're able to measure direct distances. And already we've been able to calibrate the redshift method out to 470 million light years, but there's a potential to be able to do it to a couple of billion light years. And so I think this is going to give us a more sound understanding of what's really going on, because this isn't the only idea that's challenging the traditional interpretation of redshifts. There are other models, but we got the means to deal with those attempted refutations of the standard Big Bang model.
Did you have a comment?
Yeah, I think the odd models have been around, some of them, for a long time, but it's only the data and logical analysis that can provide a true picture and a complete picture. And I don't think those models necessarily do that. Mm-hmm. Light is losing energy due to the redshift, right? I mean, it's you go from short wavelengths to long wavelengths. That means it loses energy, but that doesn't mean the light is tired. It's still moving at the speed of light, Yeah.
We have a question here. I think I saw one in the back. I saw yours too, Ken.
Appreciated your talks. It was 1986 that Barrow and Tipler put out the anthropic cosmological principle.
Yeah.
Obviously, a lot of technology has come since then. And they mentioned things like, blue dwarfs, red giants, and things like that. First of all, my question is, has the Webb not only kind of solidified some of those arguments, but are there now new arguments pointing to an anthropic principle, or maybe new factors that we have to include? Because Hugh, I think you've mentioned a couple of new ones that are starting to come out now. And so how has the Webb affected the anthropic principle formula, so to speak?
Yeah, I think it's going to give us a whole lot more in the future. It already has delivered a lot of new evidence for fine-tuning and the anthropic principle. In fact, we're assembling a team here at Reasons to Believe to actually go through the literature and bring all that up to date. Because what we have online is quite a bit out of date. And it's like the reason's out of date. It's just so much has been discovered. The job has now become monumental. And so we're literally going to have to assemble a significant team of people to try to just catch up with what's been discovered, let alone what's going to be discovered in the near future.
I'm going to go to one real quick from online. It's a little bit long. Hopefully you guys can understand it here. From what I understand, as a very recently retired high school physics teacher, general relativity governs gravity and the large-scale structure of the universe. Quantum mechanics and the other three forces govern the small-scale structure. Theories like string or M theory are attempts to merge these two big theories. We also have the standard theory of particle physics. My questions are this: how do dark matter and dark energy fit into these ideas? Where do they fit? Do they fit at all? And will the James Webb help us understand more about it?
So I would actually clarify that a little bit, in that general relativity is the descriptor of gravity and how space and time behave that we have. Quantum mechanics actually is the descriptor of all the other forces that we have. So we have quantum mechanical description of electricity, the weak theory, and the electromagnetism, weak nuclear force, strong nuclear force. Those are all quantum theories. They play out, where they play out or where those effects show up beyond just kind of normal Newtonian physics is in the small scale typically, whereas general relativity is in the larger scale. So it's not so much small and large, it's like, where do we see the effects? But when we're talking about electromagnetism, physicists have a quantum description of that. We don't have a quantum description of gravity. That's the differentiator is in there. So to a first order, James Webb isn't going to weigh in on that one way or the other, because there are relatively few places in the universe where you need both general relativity and quantum mechanics. You need them in black holes, you need them at the beginning of the universe, whatever that looks like. You just got to have the temperature and densities and scales where they all show up, and there's not too much of that where it shows up. So Webb's going to do a lot of stuff. It may make some, who knows what's going to show up. That's part of the cool thing about a new instrument is, as it's looking at reionization or the first stars, it may show up something, or it may reveal something that we just didn't even know was there. That's a lot of how even quantum mechanics came about, is we were looking in a region where we expected it to behave this way and it didn't, and lo and behold, now we have quantum mechanics. So that didn't answer all the question. I know that distinguished between the quantum mechanics and general relativity, but
you also talk about how do dark matter and dark energy fit into these ideas. We probably need to define, or the best that you can, dark matter and dark energy.
So what I would say is where they play in is we have the standard model of particle physics, which by and large governs everything, electromagnetism, weak nuclear force, strong nuclear force, and all the particles entailed in that. And where dark matter plays in is that you look at the standard model of particle physics, there are about 26 parameters in there that we can deal with. none of them serve to have dark matter. And so now you ask the question, where could you introduce dark matter in? And there are some ideas in supersymmetry that would show up that if supersymmetry is correct, for every particle, there's a corresponding supersymmetric particle, and the lightest of those would be stable. In the early universe, they would be a symmetry between all those. As the universe cooled down, we end up with all the lower energy ones, all the high energy ones decay into that lowest energy, high energy. That's a really weird statement again. To the lightest of all the high energy or higher mass particles, and that's a dark matter candidate. So we ask the questions, where might it show up? That's where it is. Dark energy is even more bizarre because you have to get up kind of on the grand unified scale before it even shows up, and that's why it's really weird. That's one of the beautiful things about physics, is that our standard model of particle physics says up to these energies we can explain everything. And so now if you got dark matter coming in, you ask, where could it be? We kind of know the scale where that is. If you got dark energy coming in, that's well beyond everything. That's why it's so bizarre that our best predictions of what dark energy should be are 120 orders of magnitude larger than what it shows up as. And so how do you get incredibly large objects canceling out and giving this really, really tiny value? That's one of the places that fine-tuning shows up. And it shows up because of our knowledge of physics, not in a, well, we don't understand this, so how could it be type thing. It's our knowledge of physics actually shows the fine-tuning, not we're trying to make it up, and so we argue we can't explain it, there's fine-tuning.
Yeah, years ago, we would distinguish between ordinary dark matter and exotic dark matter. Now in astronomy, if we talk about dark matter, we mean the exotic stuff. Mm-hmm. And the difference is this, is that we're all made up of ordinary matter, protons, neutrons, and electrons, which has the property that it strongly engages with light, with photons. Dark matter is particles that do not strongly engage with light. Either they don't at all, or they do so at a very weak level, which means they're extremely difficult to detect directly. However, astronomers are persuaded that a good chunk of the universe, about 25-26%, is made up of dark matter, because we can see the gravitational effects of it. But we want to find the particles that make up this dark matter. And I see one place where the James Webb Space Telescope could actually help us identify these dark matter particles. Namely, that a paper got published literally just days ago, making the point that the massive stars that are orbiting the supermassive black hole in the center of our galaxy, they're bright, but the stars spectroscopically measured to be old. Way older than they should be if all of their light is coming from nuclear fusion. And so the people who wrote the paper said, we think what's going on, we got these dark matter particles decaying and emitting a weak amount of light. But again, it's what I said earlier in my talk. We only have a handful of such stars that look to be bright and too old to fit if it's all nuclear fusion. The James Webb has the potential to take that database of about 10 stars up to about 50 stars. If we got it at 50 stars, I think we could really hone in. Is this extra radiation we're seeing from the decay of dark matter particles? And that could be a huge breakthrough in undergirding or understanding of the physics about dark matter. So, and it'd be really nice if we could get 300 stars. But even if we get just 100, I think it's going to give us some significant answers.
Did you have a comment, Roger?
Yeah, I think so too. The other thing that will help is make more measurements of dwarf galaxies, because they tend to have funny light profiles in their core, tend to be asymmetric, and even if they don't have companions that could cast that tidally. And a possible explanation is that it's one of these light dark matter particles that is doing the job. Energies of 10 to the minus 22 eV. Yeah. And that comes in quantum physics, comes with the Broglie wavelength, the wavelength that corresponds to that energy or momentum of tens of parsecs. And that means that on that scale, that particle is causing a wave phenomena that would affect or could affect the gravity and distribution of stars in such a small galaxy. Not on large scales, but on these smaller scales. Another thing where we see that, I talked about these caustic transits. We see them now in good numbers. We are seeing individual stars like fireflies in the night flare up for a few months and then they disappear because they go below the detection limit again. And in cold dark matter theory, it's all caused by the gravity of the cluster, of course. In cold dark matter theory, this should be symmetric along the infinity line. But the stars are mostly distributed on one side. And that's exactly what the wave dark matter predicts. Now, whether that's a paper on that, whether it's true or not, that requires a lot more data. It's a possibility, but I think Webb is going to give us more insight there. Mm-hmm. As far as the dark energy is concerned, Jeff is right.
Before you move off dark matter, is there anything about the James Webb that is, assuming our standard picture of things is correct, is there anything that would weigh in on dark matter, or would it be kind of one of those exotic things that just happens to show up in your assessment?
No, I think we could make systematic studies and show that properties of halos and gravitational masses are more consistent with one form of dark matter than another.
Okay.
And what I've currently seen, it may not be simply cold dark matter. It could be some form of wave dark matter. There's dark matter, there's no question. But what exactly it is, let's wait and see. Now, dark energy, as you said, Jeff, is even much harder. But I think there we have some hope too. There is a ground-based survey called the Dark Energy Survey, and they have measured the ripples in the cosmic structure, the large-scale structure that was seeded before recombination at hundreds of megaparsec scales that survive today as the large filaments and superclusters we see. And they've measured that spectroscopically with redshift surveys, and they married that against the microwave background result, and they say there is dark energy. Mm-hmm. But it's not Einstein's cosmological constant. For the record, Einstein predicted that the universe was expanded. He didn't like that in the 1910s, 1920s. And so he invented he let the cosmological constant, which was allowed in the equations, be non-zero. And that made the problem go away, at least for a while. And then, of course, Hubble came along with the expansion. And then Einstein said, well, the introduction of lambda was my biggest mistake. Well, we know now today that's not a mistake. There is this dark energy, but it may not be a constant. No. And the recent ground-based survey has shown that it probably varies with time. The question then is, why does it vary? And they have some Taylor series expansion that fits the data, but there's no physical explanation.
As you said in your talk, is that you get these merging neutron stars that produce about a quarter of the elements in the periodic table.
Yeah.
Guess what? Those merger events end up as black holes.
Yeah.
So without black hole formation, we'd be missing a whole lot of crucial elements in the periodic table.
So it's part of the plan, and that's the small black holes. How about the supermassive black holes? Were they part of the plan too?
Yes.
I think so. I think they're actually necessary to form galaxies. Yeah. Right. The egg came before the chicken. Yeah. I don't think we fully comprehend that and the spiritual depth of that. But anyway, that's just my take on it.
You have a question, Ken?
A question for Jack. St. Augustine said that reason doesn't cause faith, but reason everywhere supports faith. And of course, Augustine thought that faith is imparted by grace. Pascal follows in that same line, talks about reasons of the heart. But I'd like to connect that to a couple of the references that you had from Scripture. Psalm 19, in my mind, seems to indicate that the glory of God is it is perpetual, it is wordless, and it's worldwide in scope, so everybody sees it. You cited Romans 1 as well, that Paul seems to indicate that people see, understand, and know that there's a God. So in that context, what is the place of grace? Mm-hmm. I mean, as apologists, we like to pump out all of these arguments.
Right.
We want to provide the best explanation. But where is grace in that process of a person coming to look at revelation and to deal with reason.
Yeah, that's good. So I'll out myself as Reformed. So so that's the context in which I would answer that kind of question. But like Ken, so we'll have this conversation, and you can listen in on it. There's a. I'm trying to remember, make sure I remember it correctly. There's an essay by John Frame in which he is actually addressing this kind of question, and that the Spirit is not creating new information, but is helping to subdue the ways in which, in our fallen condition, we resist the conclusions. And I think that's, to me, that makes the most sense of the material you get in the Bible. That, you can, it's like you were talking about all the predictions that certain parties made about, here goes the Big Bang, and, they've got a track record of not succeeding. And so you ask yourself, has a person like that proven himself trustworthy? Even if I can't verify all of that, and reason is involved in assessing whether the person is trustworthy, and that's what we're dealing with Scripture, and also with the two books, and so reason is the means by which we evaluate those things, but we also have motivations not to follow the reasons at times, whether it be fear or preference or whatever it might be. And so that's the lines along which I would think about those things. And that, as I say, it comes from John Frame, and it's, I forget the name of it, Hermeneutics, Canon, and Authority, I think is the volume in which that appears. I've been telling myself I need to go back and reread that and make sure I remember his argument correctly.
Thanks, Jack.
Can I hijack and ask a question? All right. Okay. Thanks. So, we've had a number of displays of just spectacular pictures from James Webb, and there's comment on the beauty of them and the coloring and everything. And one of the things that I've wrestled with, and I put quote, not wrestle serious, but just kind of, what do I do with that? Is that, when you look at a Hubble Space Telescope image, by and large, it replicates what your eye would see. I mean, there are differences in there, but it's a visible telescope with some ultraviolet, but so it largely matches what your eye would see if you see it. With James Webb, it operates in a range outside what our eyes can see. So if we talk about beauty of an image that isn't what our eyes, what does that mean? And I'm curious your take on that, since you're part of the thing, but I'm just kind of curious what you guys take.
Well, it's actually quite simple. Yes, we do render the infrared colors in visible colors. Otherwise, you'd see nothing. All the pictures would be dark. But
a little less interesting, got to admit. So.
But the good news is that at a redshift 3 to 6, the infrared filters sample exactly the optical wavelengths you're used to. So in the rest frame, for most of these distant objects, you're looking at the colors you've seen all along. That's broadly speaking. It's not true at the very highest redshifts, but not true at the very lowest redshifts. Mm-hmm. But for the bulk of the galaxies, which are redshift 1, 2, 3, you're not violating anything.
Interesting.
You're rendering invisible colors to the visible light that they were emitting before they were redshifted. And
okay.
Yeah. So I think if you think of it that way, the pictures are actually quite good. Now, for the objects in our own galaxy, you render the infrared colors in funny orange or green or blue or however you like. That's not how your eyes would see it if you were like a fly with an infrared vision. But
and I have to say, I find the images just fascinating. Yeah. I mean, the texture and how things look in the infrared is fascinating.
Yeah. Oh, yeah.
I have wondered about that question.
What I get from a lot of lay people is they say the James Webb Space Telescopes can't be real because the images have all been distorted and we can't trust what we're seeing. And it's been helpful for me to explain to them, yes, they're infrared, but they're all shifted by exactly the same degree into the visible so we can enjoy what we're seeing.
Yeah.
There is no distortion. Everything's being shifted by exactly the same amount.
That's right.
And then people say, okay, now I can trust it.
Yeah. we make it as trustworthy as we can, and it's.
And see, there's an example of reason establishing credibility there, and those of us who don't have the tools to, to verify, nevertheless have good grounds for trust, and we're acting responsibly.
Let's go over to one online, and then we'll do another question in here. Kind of goes back a little bit more on the theological side. Any ideas on how the Holy Spirit interacts in or with the cosmos and creation, since the Bible clearly credits him often in this role? You want to take that first? Or?
Okay, well, it's complicated. Sorry. A couple of things. One is traditionally the way that both Jews and Christians have talked about God's action in the world is that God makes everything, he governs everything, he sustains everything. And exactly how he sustains things, especially in their interactions, we confess it, but we don't think that that's physically detectable. And the where that comes down is so everything that happens is God's action. So when we are teaching our children, in my church we use a children's catechism. Who made you? And the answer is God. And a little bit later, they'll learn some of the biological details of the process that God used. And so talking about the process, this also comes back to the Krauss quote as well. Mm-hmm. Talking about the process isn't the same as setting that over against that God did it. They're not a zero-sum game, as that's the logical thing. So that the Holy Spirit is the agent of God, portrayed there as the one who is sustaining it all. But there's also governing it all, and there's also the possibility of things added to the physical processes. And so, especially like in Genesis 1, the Spirit of God was hovering over the waters. That's there to indicate that something more than just the physical processes is going to be happening there, and so that you have the origin of living things and so on.
Anyone else want to comment? Or? You're good. Question in here, Joseph.
All right. Thank you very much, everybody, I love the conversations. I do a lot of interactions with the younger generation, and they, of course, watch Marvel movies and all that kind of fun stuff. Curious, does the James Webb Telescope help us at all understand the theory of multi-universe? The multiverse? Yeah.
Spideyverse.
To first order, no.
Okay.
And I hesitate on that because there was something I was reading and preparing for this weekend where it had some possibility of talking about what might actually form the galaxies. There was this idea that black holes might be able to pass through the quantum gravity phase and actually seed galaxy formation. So in that sense, there are put this in the maybe it's the wave dark matter, maybe it's something else. There are speculative theories out there that maybe it does, but really where the two prime motivations for positing a multiverse ultimately flow out of inflationary cosmology. The mechanism that the way inflation works makes our universe far larger than what we can see. The way we understand inflation to work produces a multiverse. If we're wrong on our understanding of inflation, then maybe a multiverse doesn't exist. But to a good first approximation, James Webb doesn't weigh in on whether inflation happened or not. The other big driver is kind of a quantum mechanical one, and again, that's not something that James Webb's going to weigh in on. It's what interpretation of quantum mechanics is, and that's much more driven by laboratory type experiments that are going to drive that. So it's a fascinating topic. I love thinking about it. I don't think the multiverse is a threat to if we live in a multiverse, that wouldn't surprise me at all as a Christian, to be honest. I read the Bible. There are other created realms. That doesn't bother me. So,
you comment?
Oh, I was just going to say that not James Webb, but There is a potential for better gamma ray telescopes to come online. And those gamma ray telescopes have already penetrated the quantum gravity era, that era where we're looking at the physics of the universe when it's less than 10 to the minus 43 seconds old. And so far there's been a penetration of a factor of 8 into that quantum gravity era. The good news is those observations are consistent with the universe having a beginning. But we'd love to penetrate that even more. James Webb won't help us, but these gamma ray telescopes that astronomers hope will be funded have that potential.
Is that responsive, or do you want to follow up?
I was just curious, because I get students all the time that talk about this kind of stuff, so I'm just curious.
You know, there's a book that somebody at RTB wrote called Who's Afraid of the Multiverse that might be helpful for that. Yeah, I wrote it, so.
No. Yeah. Let's go over to one online. Again, a little bit longer here, but hopefully we can get the gist of it. Jeff said that the Big Bang theory is universally accepted in the scientific community. However, some scientists seem to want the universe to not have a beginning, even if the Big Bang is true. I believe that Stephen Hawking was included in that group. I would be interested in hearing comments on whether the search for a Big Bang universe without a beginning is purely philosophically based, or if there is actual scientific evidence to suggest that that could be true. And I think you wrote another book called Escaping the Beginning.
I did, right? Yeah, just so what I would respond to that is when a scientist talks about, or when a cosmologist talks about Big Bang, they're talking about the universe started in a hot, dense state and then everything after. They're not really addressing the beginning, in large part because to address before that, or what might be, needs a quantum theory of gravity, and we don't have that. So precisely where you need our singularity theorems to hold is exactly where they all break down, because they all have some classical component to them, which means they don't apply to quantum mechanics. So there's the reason why people are skeptical or hope there might be a beginning is that's part of the reason for that. So there are two physics reasons. One, we don't have a quantum theory of gravity. And in the same way, when general relativity came on the scene, the way we thought about creation was very different. Before general relativity, time and space were these absolute quantities that everything happened within. When general relativity came onto the scene, time and space are now these dynamic quantities. We just thought about the universe differently. And so the idea being, until we have that quantum theory of gravity, we can't actually answer that because we don't know what the right way to think about space and time in a quantum gravity era is. So that's one of the reasons. The other reason is that physicists particularly love symmetry. You know, I mean, we've talked about symmetry when I was talking about the electroweak and how the electromagnetic and the weak nuclear theory are actually the same thing, that when you get up to high enough energies, there's a symmetry that has been broken. Symmetries flow out every time we talk about a conservation law. It's ultimately founded on, or it ultimately derives from a symmetry in creation. And so the reason why we talk about conservation of angular momentum is a symmetry in space, that you can translate in space and everything's the same. For there to be a beginning, there has to be an asymmetry in time. And so physicists love symmetry, and the fact that there's a beginning means there's a lack of symmetry. So there is a physics reason why you want that. Now, at the end of the day, the way the universe is trumps the way I want the universe to be. If I want the universe to be a certain way and it's not, I'm wrong, not the universe in that sense. So even though there may be these physics motivations for it, and nobody questions there are theological motivations often in these discussions, but there are kind of good physics reasons to think, or at least have a hope that there isn't a beginning. That would be my response to that question.
Yeah, and I would add, Jeff, that it's right that we don't have a quantum gravity theory, but we got observations that eliminate some quantum gravity theories. And what I find encouraging as a Christian, the ones that are being eliminated are the ones that are supporting an atheistic worldview where they can escape a beginning. On the other hand,
I would agree with that, with the caveat that most of the ones that people are investigating are the ones that tend to not have a beginning, because those are the ones most people find interesting.
yeah, but I mean, we are making some progress on constraining the quantum gravity theories. However, I do run into physicists, theoretical physicists say, before I can join you as a follower of Jesus Christ, I want a complete quantum gravity theory. And it's like, well, for that to be possible, we need to be able to make measurements at infinite energy. That's never going to happen. But aren't you impressed with the fact that all the observations we have are consistent with a beginning as opposed to no beginning? And we keep extending the boundaries, and they all support that there is a beginning. And, you've heard me use the analogy about the fact that, I don't have absolute proof that my wife exists. All I've got is a high degree of probability, but I can't eliminate the possibility that she possibly doesn't exist. But every year I'm married to her, I get more and more observational, experimental evidence that she really does exist. But I'm never going to reach the point where I can say I've got absolute proof that she exists. And I'd argue that's true of every scientific conclusion we're able to make about anything. And I think it's philosophically inconsistent for an atheist to say, I won't believe until I have absolute proof. But yet I hear that's where a lot of them are going. Yeah. And so, again, maybe appealing to the philosopher Kurt Gödel, we're going to have incomplete information about anything that's truly meaningful. And it's like, I'm okay with that. I was willing to commit to my wife as she walked down the altar on our wedding day, even though I had incomplete evidence that she really existed. Yeah. I had enough evidence.
And what you're describing, I mean, that everything that's important to us, that's the way trust is fully rational in that. Mm-hmm. Yeah.
Now I have this picture of like Hugh getting roses and going, "Here, Kathy, I believe that you exist even more today than yesterday." Sounds like a song too.
She's commented on how romantic that
is. You should tell her that her wave function has collapsed and she's really there. That's a quantum joke.
It may have just decohered, and we're in the same decoherence, though. I mean, come on.
That's how romantic us scientists are.
I'd like to read a qualifier that we're not offering marriage advice today. Just so we don't get in trouble.
He actually has that.
No. Question in the group here. All right.
If it turns out that data does show us that the black holes come first, is that going to result in a maybe it doesn't change the Big Bang, but is it going to result in a major modification of it?
Yeah, to me that's one of the most exciting things to look forward to. What is the role of the formation of these supermassive black holes in the early history of the universe? Are they really the ones that are the seeds of the formation of these galaxies, or is it the other way around? And I think that's where we're going to see the greatest progress in narrowing down what kind of Big Bang creation model we're really dealing with. But as I mentioned in my talk, we're dealing with a database of 4 early supermassive black holes. To get the answer, we're going to need a much larger database. I find it intriguing that we found 3 at 1 billion and 1 at 2 million. And, is there gradation in the way these things build up over time? But I hesitate to draw any conclusions based on just the 4 we've seen so far. But I'm encouraged that people using the James Webb, they're saying, hey, we got to go after this. This is really big. Let's actually get some more data on this.
So I would say that was part of what I was I was trying to emphasize in my talk, is that when you look at recombination, which is where the cosmic microwave background radiation was emitted, and then our next observations where we can actually have definitive data is, galaxies are there. And the question, we had a idea that just said, okay, these fluctuations somehow grow and make galaxies. That was effectively, we had a couple of models that is like, this seems plausible, this would be an explanation. But they were explanations in the lack of data. So in no way does coming in and saying, we find out, black holes form and then galaxies form, or maybe stars form and they accumulate and make galaxies and then they form, or big stars form and collapse to black holes and then galaxies form. All of those are consistent with background radiation to galaxies form. We're just now getting more details on the process. So it doesn't change the Big Bang model. It just takes a place where we said, oh, and we think this happens to, oh, now we actually can measure what happens.
Thank you all. Really just enjoying this. I was expressing earlier that I wish we would do this more often, because really I think that these discussions are important. The question that I have is, in Hebrews, the Lord talks about how the heavens are going to wear out like a garment, and he's going to roll them away like a robe. So what clues do we have as to why Scripture makes that statement?
Yeah, that's in 2 Peter. And you'll find some complementary passages in the book of Isaiah about God wrapping up the scrolls all end in a fiery heat. And yeah, there actually are some Big Bang models that would predict that's the way the universe is going to end. But again, we're dealing with a small database. There's only 3 passages in the entire Bible that bring that topic up, and both of them are a single verse. So it's kind of like the fact that we're looking at these 4 supermassive black holes. It's like we need to be cautious when we got a small database. And there are many theologians who've looked at those same passages and saying, we think it's a mistake to interpret those literally. Maybe we can interpret them literally, but maybe they're figurative. And so if they're figurative, what are they figurative of? And, I'm confident in reading Scripture that, God created this universe to eradicate all evil. And when evil is eradicated, the universe will have fulfilled its purpose. And God will usher us into a brand new creation where the physics is different, the dimensions are different. So we don't have to wonder, are we going to be subject to this pervasive law of decay forever? No, the promise in Scripture is eventually we'll have bodies that will never decay. And, we won't have to worry about decay anymore or worry about death. And so, but as Jesus said, in this world you'll have tribulation, but take heart, I've overcome the world. Or I like to quote as a paraphrase of that text, in this world you'll have thermodynamics, but take heart, I've overcome thermodynamics. And so, I don't know about these passages that talk about the end of the universe. In one sense, it doesn't really matter that much. It's like God's going to eradicate evil, and when he does, the universe will end, and we get to go to a far more fulfilling realm. So I think that's the key takeaway.
Jack, did you have any comment on that? Nope.
I would affirm everything Hugh said, and I would just throw in one little speculative, or from a scientific perspective, the capacity of our universe to support life will end. That there is a terminus to how long our universe can support life. So the idea that this is a place we can live forever is just a non-starter in a very real sense. Another interesting, maybe it is, maybe it's not type thing. But there is, when we found the Higgs boson, as we measured the mass of it, it turns out that it has this odd property that it's right at this mass where it's possible that our universe is not in its ground state and it could decay to the ground state, in which basically the fabric of space-time would burn up. So whether that's true or not, I don't know. But the idea that there's a scientific plausibility to that, whether it's the truth or not, I find that interesting. So.
And you're not telling us it's going to happen tomorrow, right?
No. That's the interesting part, is it could already be happening, because when it comes, it travels at us at the speed of light, so we're not going to know.
So can I take on an insurance policy against it?
Go ahead. Even if you win, you're still wrong, because we're done. So.
Well, won't it be anybody
if you
around
read the
to
news,
collect
I think it's already happened.
Yeah,
What's that?
So I think the particular passage you're thinking of is at the end of Hebrews chapter 1, where it's using Psalm 102. So Psalm 102 is a psalm addressed to the Lord, the God of Israel, and then the author of Hebrews is applying that to Jesus as the one who became incarnate in Jesus is this one of whom all these things are true. And so the stress there, if my memory is correct, is the eternality of God, the transcendence of God over all these questions about whether the universe can survive. And so that the ground of confidence, you have the letter to the Hebrews ends with Jesus Christ the same yesterday, today, and forever. And so the sameness there is not the sameness of monotony, but the same in terms of transcendence. And so the things that Hugh and Jeff are talking about are not defeaters to God's ability to produce a new heavens and a new earth, this new realm in which we will live.
I like his answer.
So I was going to say, of course, on a short time scale, 5 billion years, I had a chart on this. Hubble, the astronomer, discovered that galaxies move away from each other with a speed proportional to distance, right? With a few exceptions. Andromeda is moving towards us. Then 100 years later, the Hubble Space Telescope discovers that Andromeda is not only moving towards us, but also has no lateral motion. So it comes straight at us. It's not going to pass by in 5 billion years. It's going to hit like a pancake. That's going to be a dramatic event. Now, thinking of supermassive black holes. Now, the sun will be dead by then, so no reason to sell your real estate. But I was actually thinking about something more long-term on the topic of forever. If Webb manages to say more about how the cosmological constant, I should really call it dark energy, changes with time, and I think that's possible, that it can with supernovae and so on, we might find that the W parameter is permanently negative, right? And that will cause a big rip. So it's like a super acceleration. Not only does the universe accelerate, but it accelerates its acceleration. And at that point, far in the future, everything will disappear. That's what you were talking about, right? Mm-hmm. Everything will rip apart. So maybe that answers the question of what was posed, the heavens.
Yeah, if you want to read about that, we have an article on our website called Giving a Rip About the Big Rip.
Yeah, yeah, there you go. That's a good one. Yeah, a rip about.
Which is why you don't let astronomers title their own articles.
Or name stars. We have a question online that kind of goes, I think, a little bit to what's being talked about here. Again, a little bit long, but we can discern what's going on here. The early universe was hotter soon. The early universe was hotter soon after the Big Bang. Was the fabric of space closer together, which may have allowed the super large stars to be hotter? How does the stretching of the fabric of space affect stellar and galaxy formation? When a dwarf galaxy merges with the Milky Way galaxy, does stellar formation occur faster today or soon after the Big Bang?
That's a good question, and it's like, star formation doesn't happen until the universe is roughly 200 million years old, in which case a lot of that question, because the universe is already expanded enough where it can't play that kind of a role. But it is true that as the universe gets older and older, the merger of galaxies together becomes less and less, because the galaxies are now farther apart from one another. So as you look back in time, and this is what James Webb is telling us, we see that merger events are much more frequent as we look, say, 12 billion years ago, 13 billion years ago, than we look today. What I find really interesting about our own galaxy, you got to go back 11 billion years before you find a merger event. And so one of the benefits of our Milky Way galaxy is that it's been undisturbed for 11 billion years. And it explains why we have such symmetrical spiral arms and why our Milky Way galaxy is such an optimal place for advanced life.
Aren't there evidence of small dwarf galaxies being absorbed into the Milky Way?
Yes.
So it's not entirely isolated, but just major.
No,
collisions
our galaxy is eating tiny dwarf galaxies, and it must in order to sustain the spiral arm structure. But the last time we had a galaxy merge with us, kind of like what we saw with what David Block was talking about, how,
where M32 passed through.
M32 passed through. The last time we had a galaxy as big as M32 merge with us is 11 billion years ago. And so galaxies, they're still dwarf galaxies, but they're massive enough where they distort the structure of the galaxy. And so, yes, we've been eating tiny dwarf galaxies. In fact, what I find interesting about galaxies, for them to be optimal for advanced life, they have to have a highly fine-tuned diet of just the right tiny dwarf galaxies on a regular basis. And so it's like our Milky Way galaxy needs a dietitian.
Yeah.
And what's amazing is how the large and small Magellanic Clouds play a crucial role in making sure we have just the right diet of consumption by our Milky Way galaxy. So it's not only humans that need a dietitian, galaxies need dietitians.
I can see the shirts now.
Yeah.
I'm on the Milky Way diet.
Yeah.
That has two different meanings, by the way.
I love the imagery there.
I want to go back real quick to this. You mentioned that the overview effect. There is this sense, both the secular scientists, the religious scientists, that we look at these things, we get a sense of awe. In religious experiential language, Rudolf Otto, who was a famous theologian, talked about having a numinous experience, a sense of awe, dread. Just like I'm small, this thing can crush me, kind of an idea. And I've been to the Grand Canyon a number of times, and it's always fun to go to the Grand Canyon with someone new who hasn't seen it, because either you're driving up and suddenly you see it, and they think, well, that's a painting. It's interesting that that's what they refer to. Or you can stand on the edge and someone comes to it. And I've never heard anyone come up to the edge of the Grand Canyon and go, I'm so huge. I am wonderful. I am so big. You just don't do that. And it's interesting when people see these images like you were showing, Roger, there's this numinous experience that people have, this overview effect we talk about with astronauts. Can we talk about that a little bit more, Jack? And then how can we use that? I would like to hear, how can we use that to be a bridge to talking about science, faith, the gospel? I'd love to hear your thoughts.
Well, I think what we need to do first is distinguish it. I'm thinking about the Grand Canyon, for example, distinguish the sense of awe and wonder from the sense of that's dangerous, I better not slip. That's good advice. Okay, so don't get too close to the edge and all that. But but there's more, and so we want to resist anybody who wants to reduce that sense, and then ask, okay, does it correspond to something? I mean, is there a sense of an obligation on your part to feel humbled before this majesty? And is that an indicator to something about not simply your place in the universe, but your relationship to what lies behind the universe? So, I mean, just try to help people see, first of all, it's not just that, but also that it is an indicator. And now it won't work on its own, but it then, works, you use it as something that builds into this larger network of reasons and so on.
Mm-hmm. You just made me think of Samwise in the movie The Fellowship, where he walks into Moria and he sees all the pillars and he's like, that's an eye-opener. And I could see him saying the same thing, looking at some of those pictures. Yeah. You have thoughts, Roger?
Yeah, the pictures are just out of this world, literally. I mean, and who would have thought if you had to model that up front with a supercomputer or AI or chat GPT or whatever they call it these days, you could not have possibly come up with it. There is a sense of awe there that it's beyond what we could have conceived of ourselves.
Mm-hmm. Yeah, I mean, Richard Dawkins famously said that the universe has exactly the properties we would expect it to have if there were no design. I mean, words to that effect, and yet there are places where even his humanity shows through. Where he marvels at things and so forth, and so I think we would want to help people see that statement by Dawkins is not in touch with reality.
I remember watching in the 70s with my dad 2001: A Space Odyssey. Right. And there's a moment when Bowman, the astronaut, he goes into the monolith and he says, "My God is full of stars." And now we have to say, my God is full of galaxies.
Yeah.
Not just stars, but just, the structure of all the galaxies in that. Any thoughts on this overview effect, this sense of awe, how we can use that in evangelism?
Yeah, well, it's been said that when you look up at the sky, you need to see at least 2,000 stars to have a sense of awe. And the more stars... Well, if you go outside tonight, it's relatively clear. It's a struggle to see 30 or 40 stars because of the light pollution of the Los Angeles basin.
Yeah.
So you don't get that same sense of awe. But it's also true that once you get past 2,000 stars, Abraham, there was no light pollution he had to worry about.
Yeah.
He could see 15,000 stars. Today, it's a struggle to see 6,000, even in a very dark site. But it is true that the more you can see, the more that sense of awe. It's like, who am I? Who is this creator that's made all this? And that's where I think these telescopes we have today. And so I think we all need to be active as followers of Jesus Christ. Get this stuff out there. It's one reason why I display the James Webb images on my social media. I want people to have that sense of awe and to recognize, hey, it's not just awesome, it's incredibly beautiful. It's symmetrical. Just to have all those adjectives that David put up about this sense of finesse, I think we need to do a better job communicating all those adjectives he put up there.
Jeff, you were going to comment?
That was just one of the shifts I found when I first started doing apologetics a couple years in. It's like I would learn to make these arguments and say this or that, and there was part of me that, a new discovery would come out, and it was kind of a little bit challenging to the Christian faith. And my initial response was to deal with the argument instead of just appreciate the fascination of the discovery. I'm being genuine in my talking about the James Webb Space Telescope. It is a technological marvel. It's just cool. I think there's being appreciative, and to your point, or somebody, I forget who said it, there is a fallenness, but there's also this grandeur of who we are. We're creating in God's image, and just being fascinated with creation and showing people the fascination in creation. I think that at times will make a connection, that a good argument pave the way so that the argument might be heard, as opposed to just being something that becomes an argument.
It's only 40 miles away where this James Webb telescope was being put together. And I had the privilege of actually going over there to
you see it?
Yeah.
Yeah.
Grunham.
Yeah.
And just seeing what they were doing. And it's like, the meticulousness in which they were engaging this telescope and the protective gear they were wearing. It's like we're created in the image of God. God gave us the capacity to some degree to create like he does. Yeah. And just being there in person and watching how they're putting this amazing instrument together. The thing that astounds me, it weighs less than half of the Hubble Space Telescope. But look how much bigger it is. Look how much more capable it is. But look at the engineering that made all that possible. And the fact that they could put it in that Ariane rocket. I think that was part of it. They knew that there was a high probability that rocket wouldn't fail.
That's right.
But it's because they had this lightweight telescope inside that they can make all that happen. It's like, when you think of all that went through, you've been involved in this over many decades. It's like, there's a sense of awe that you see there that kind of matches what we see when we look at the heavens.
So there was an episode in the old Star Trek series from the 1960s. And so Kirk and one of the security guys, one of the red shirts, have to set this bomb to destroy this evil alien, and then they have to be transported out of there at just the right moment, so in order to have dramatic tension, of course, is it just the right moment? And so Spock and Scott are back on the Enterprise, working with all the settings and so forth, and they finally transport the two guys on there, and Scott says, "Thank heavens," and then Spock wants to correct him. It was Mr. Scott. It was our manipulation of the controls. The deity had nothing to do with it, and that sounds logical, but it's false. And we have to help people see that that kind of limiting of marveling is actually harmful.
We have about 10 minutes. We're going to take some more questions here. Just on the documentary I mentioned, you can view it on Netflix still right now. Amber Strawn, I don't know if you met Amber before. Amber
She
Strawn.
was my student.
She was your student? Okay, even better. She worked on the project 15 years. She's a NASA astrophysicist. She said, quote, those first images from the James Webb will help us get closer to answering those questions of where did we come from? How did we get here? Are we alone? Mm-hmm. And she continues, she says, the universe is so big, there's got to be evolved conscious life out there. Your thoughts, comments?
Well, there could be other life out there. I don't think the data is conclusive. Sometimes when I read the newspaper, I don't think there is any intelligent life out here. But sorry, I couldn't resist that one. No, but
that's exacerbated by social media.
This was a joke, okay? But yeah, all the elements are there, the building blocks are there, but that doesn't prove that it's out there. If it's out there, I personally think we're lucky that they haven't been here yet.
Because?
Well, look what we've done to the American Indians a couple of centuries ago, and we meant well, by and large. And we destroyed their culture and their health and everything else. Imagine a spaceship full of aliens coming here. I think it'd be a disaster for mankind. I don't think it'd be good. Yeah.
The author, Arthur C. Clarke, has some interesting books on that.
Yeah.
One called Childhood's End.
Imagine the first question we asked them, is there a God out there? What if they say no? What if they say, yeah, we had somebody that came to our planet to save us? I mean, any contact with alien life is going to forever change our society in a way that we probably didn't want. I'm so glad they haven't been out here yet. So in my AST 111 class, I think I told some of you guys this, I make the students, the solar system course with some basic physics, I make them offer a debate at the end of the semester, the great debate, the aliens, are they out there or not, have they been here or not? And many of them believe that has happened, and others haven't. And I lay down one rule, say you can argue either way. There will be two camps debating each other the final day, but you have to use the laws of physics. You have to take into account that all these aliens would have the same periodic system as we do. And don't give me this garbage that they came from the Virgo cluster, the Coma cluster. Those titanium spacecrafts that they have, made out of those one of those 103 chemical elements, they better well swim through at a reasonable fraction of the speed of light through that intergalactic medium. That's 10 to the 7, 10 to the 8 degrees. Please, how are we going to make that happen? Mm-hmm. An interstellar medium, 10 to the 6 degrees after supernova explosions. We're in a cool spot, literally. How are these aliens going to get here? Mm-hmm. They may well be out there, but my personal take on this is I'm so glad they haven't been here yet.
You just have to watch the movie Independence Day.
I did.
Question over here.
Yeah, and this may seem to be smack of a lack of gratitude, because everybody's now just enjoying the results that are coming off of the James Webb.
Yeah.
But the question is, what's next?
Yeah.
Right. What's the next telescope? What's the next big project? And maybe building off of that, what would you like to see in terms of observational capacity that could answer the big questions that the James Webb won't?
Well, there's two things coming up, right? There's the Roman Space Telescope, which is sort of like a super Hubble, works a little further into the infrared, but not like Webb, sort of visual to the near infrared. And it has 100 times the field of view of Hubble. So it will do a really wide panoramic Google sky, if you wish, like Hubble has done in very tiny fields of view. And it will find many stars that are hosting planets through planetary transits or things like that. Then there is the Habitable World Observatory, which is a larger version of Webb, pushed further into the UV optical, which would be much more difficult to make precisely than Webb. And that is designed to find, building blocks of life, or at least chemicals that are conducive for for life on Earth-like exoplanets. And that telescope, if they make it 6.5 meter or bigger, is probably just large enough to get, talking with Hugh Ross's words, get more than a handful, but get a sample of several dozen. And then you could begin to ask the question, is there actually in our solar neighborhood planets that really could host life? There's a lot of exoplanets out there, no question. Many of them have the chemical building blocks that you'd like to see from what we see with Webb. But is there really liquid water out there? Is there oxygen out there in the atmospheres? Is there ozone in the atmospheres? Once you find one with ozone, then you got a really interesting case. But I think we're far away from that.
How does that correlate with the 30-meter telescope projects that are going on? Are they complementary, doing the same sort of thing?
Yeah, the 30-meter telescopes always have higher spatial resolution if you use them with the adaptive optics. They also have a much larger light bucket capability, so they are better for high-resolution spectroscopy, which helps you find these chemical elements. The disadvantage that the ground-based telescopes have, as I said at the beginning of my talk, the sky in space is between a factor of 10 and 100,000 times darker than we have here on Earth. So that turns these small space telescopes into huge facilities compared to the ground-based, just for the purpose of detection of faint objects. So they are complementary in that sense. So if you want to find a faint exoplanet next to a brighter star, a space telescope would be better for that, unless you get your ground-based adaptive optics just down to an art. And they're working on that.
Yeah, and a couple of instruments that I think are going to help in the relatively near future is the Europeans have sent a telescope to join the James Webb a million miles away from us. And that telescope's project is to examine the baryon acoustic oscillations, basically the structure of clusters of galaxies and galaxies. And that's really going to help us really deal with this Hubble tension issue. So that's already up there.
Euclid, right?
Yeah.
Euclid,
Yeah, Euclid. Yeah, Euclid. The other one that I think has got some real potential is a square kilometer array. That's a radio telescope that's going to be partly in Australia and partly in South Africa. And part of it's already been built. But the goal is to have a collecting area of 1 square kilometer. That huge of a collecting area at radio wavelengths, that's got the potential to make some really exciting discoveries. I'm also, the Lucy instrument in the backside of the moon. What we basically have happening next year, they're putting 4 rather tiny radio telescopes there, and they're basically saying, hey, is this technology going to work? Are we really going to be able to get some good data at very, very long radio wavelengths? But if it works, we can go back and put a much bigger array on the backside of the moon. And that's where I think we got some really exciting potential to explore what's called, that dark ages of the universe. So
how are they going to deliver that to the moon?
It's all done robotically. Just like they put telescopes in Chile robotically. They're using the same kind of thing to robotically put these instruments on the backside of the moon. The one threat is that the Chinese want to put a bunch of telescopes orbiting the moon. And so astronomers are saying, can you please shut off your telescopes that are on the backside of the moon? Because of, if they don't, and even if they're shut down, make sure that when they're shut down, there's no radio noise coming out from the instrumentation that's on board there. Because even the tiniest amount of radio noise basically disables that set of telescopes. So we need to protect the backside of the moon. It's the one place where we can isolate telescopes from all the radio interference of the Beverly Hillbillies and all that's being broadcast throughout interstellar space.
That would be cool shirts too. I'm protecting the backside of the moon.
Yeah.
Yeah. People are like, what are you talking about? You're into a conversation. Tracy, do we have time for one more? Or
2 years ago in this meeting, we briefly talked about the importance of the doctrine of inerrancy of Scripture. We said if you lose that, we lose Christianity, and by implication, we would lose science and faith, because science will be there, but there will be no reliable source for faith. So how do we teach the body of Christ what the doctrine of inerrancy of the Scripture is, how it works, its implications? Because confidence in the Bible is declining rapidly. I think that Ligonier Ministry, every other year they do a survey. 2 years ago, confidence in reliability of the Scripture was 26%, and then last time, I think it was last year, it was 15%.
Yeah, well, I authored a book called Rescuing Inerrancy, but I remember having a conversation with Wayne Grudem, and he was the youngest theologian that was part of that 300-plus theologians who produced the International Council of Biblical Inerrancy statements. But I remember him saying every generation of Christianity must fight the battle for biblical inerrancy. So I think one reason why you see that decline that Ligonier Ministries has pointed out, we've not been fighting the battle for biblical inerrancy. We need to bring that back into our ministry, into our churches. But I think it's crucial, too, for organizations like Reasons to Believe and for churches and seminaries, actually have the principals sign their adherence to the inerrancy statements. And if they feel in good conscience they can't, let's have a discussion. I think that's what Wayne Grudem meant about fighting the battle. Let's not ignore the subject. Let's actually seriously engage it. And don't condemn somebody because they say, look, I'm not sure I can sign on to that one statement. Let's talk about it. Let's dig into this. But if we keep ignoring the issue, then we shouldn't be surprised that there's this erosion that we see documented by Ligonier Ministries.
Yeah. And go ahead. No.
Well, I mean, there are other factors in play. Coming back to Ken's point about the good and the true and the beautiful, and I think that there can be sort of less than just rational reasons for thinking that no, this can't be true because it doesn't appeal to me. A lot of the moral questions and so forth. That's where the rubber meets the road for a lot of people. And so that what we would really, ideally would want to show is that a doctrine of inerrancy, say like the Chicago Statement, which I think is a good statement, that if it's really adhered to and put into practice, that it produces something that is really appealing. And it's also important to be clear on what the doctrine does and doesn't say. I've read people who think that the doctrine that's articulated in the Chicago Statement requires, say, young Earth creationism, which it explicitly doesn't. Mm-hmm. And then there are those who want to attach any notion of inerrancy to certain other doctrines, mm-hmm. and so forth. And so, part of the task is to make sure we're really clear on what it does and does not involve us in being committed to.
Well, that's what I admire about the International Council of Biblical Inerrancy. They carefully define what biblical inerrancy is and what it is not. And yes, they produce the statements, but they also produce 2,000 pages of commentary that accompanies those statements. And I love the fact that Dallas Theological Seminary said, we're going to archive it, and it's going to be archived in perpetuity at no cost so that anybody can access it. So I think that's part of how we can sustain inerrancy. But my own personal experience is that when people get involved in actively sharing their faith and seeing people come to faith in Jesus Christ, for them, inerrancy is a no-brainer. They begin to see how crucial this is in growing the community of people become followers of Jesus Christ. Whereas people who are doubting biblical inerrancy, if you dig into their lives, often you see that they've kind of backed away from that mission of bringing people to faith in Jesus Christ, which means maybe encouraging the ministry of evangelism and doing it in a respectful, gentle way, as it says in 1 Peter 3:15. Maybe that's the key to sustaining belief in biblical inerrancy.
So as we finish up here, if I'm going to go home, I might talk to my wife. I have 2 boys I might talk to, and I have to tell them a quick summary of what I learned today. You know, if I went to each of you, what do you want people to take away from your talk that I could hand over to someone else? And I know that's a hard thing to do, to, you know, distill it that much. But Jeff, if I could start with you, you were David's not here right now, but what do you want the takeaway to be?
I would say that there is strong reason to believe that our current picture of Big Bang cosmology is a good picture of the universe. It's a reflection, or it aligns well with the biblical description of creation, and we can be very confident going out and talking to people about the wonder and majesty of creation, and know that Christianity holds up under any sort of scrutiny that comes. Be willing to engage those conversations, even if people are going to be antagonistic. If they're going to push you, you're going to be okay. Just being willing to dig in and do it, and you'll find that it works.
God's not afraid of our questions.
Absolutely.
We shouldn't be. Let me go over to Roger. What would you want people to take away in encouragement?
Well, Webb is really cool. It's 40 kelvins, and it produces really cool pictures that show the glory of God, and that support the Big Bang. I haven't seen anything wrong with the Big Bang. We'll see where we go, but we'll start fine-tuning things in the sense that, you know, we'll understand better the Hubble tension and the black hole role and all that. But it's a marvelous instrument that's providing great images and even greater promise, I'd say. Yeah.
James Webb is cool. I got
it.
Yeah,
cool.
Yeah. Over to you.
Yeah.
Hugh.
Yeah, I think the takeaway is, even on the biggest scale we can think of, the book of nature is sustaining and verifying the book of Scripture and our need for a relationship with Jesus Christ.
And just to build on that, if you have these 2 books at work, you have the book of nature testifying to the immensity of God and the incredible wisdom and power that must be at work to produce and sustain and govern this. And then you also have the scriptural account of God's interest in people who worship Him. And just be reminded that the God whom you worship is this magnificent one who actually wants you to know Him. And so the magnificence and also this intense interest in every detail of our lives, and He's big enough to handle every detail of our lives.
And if I can make a shameless plug, the James Webb Space Telescope is giving us new reasons to believe.
Yeah,
I love it.